Hi everyone, welcome to my instructional video on the Fermi Gamma Ray Space Telescope. As you can see by the picture, it's this gorgeous big machine cruising around in space, gathering beautiful information and data for us to learn about the universe. So let's learn about it. So who is the telescope named after? So Enrico Fermi was an Italian physicist. He did a lot of things, made a lot of contributions to the field of physics. He's actually called the father of the atomic bomb. For the patents that he holds on the use of nuclear power. He was awarded a Nobel Prize in Physics for his work on radioactivity. So what hasn't this man done? Let's close this. Right now. He's done tons of research. He started in statistical mechanics. He developed a model that explained the neutrino. What hasn't he done? Basically, he served on a committee that advised the Atomic Energy Commission on nuclear matters and policy. He did a lot of work in particle physics as well. So he has a lot of things named after him. Enrico Fermi Institute, the National Accelerator Laboratory, the Fermi Telescope, and an element is actually named after him, fermium. So, that is who the telescope is named after. So, what does this telescope do exactly? Basically, it gathers gamma ray radiation. So this is the most energetic form of radiation. And basically, what we can learn from what it's gathering is information about black holes, for example. With this telescope, scientists can study subatomic particles at energies that are much higher than those in ground-based particle accelerators. So what we're learning is a lot about the early universe and how it's changing and changing in size and how it's changing at all today. So it's a gamma ray telescope. So what are gamma rays? Let's find So gamma rays have the smallest wavelength and the most energy of all other waves in the spectrum. So they're actually extremely dangerous. They can kill living cells. So they can travel great distances, and they're produced by the hottest regions in the universe. So they're produced by things like supernova explosions, radioactive decay, black holes. So, unlike other kinds of radiation, gamma rays can't be captured and reflected in mirrors. So, the Fermi telescope and any gamma ray telescope uses a process called Compton scattering, where a gamma ray strikes an electron and then it loses energy. So that's how the telescope gains information about the radiation. It's actually kind of hard to understand. So, there is a phenomenon called gamma ray bursts, and these release tons of energy, more energy in 10 seconds than the sun will emit in its entire lifetime. So that's insane. So scientists think that gamma ray bursts occur every few million years here. And it's kind of a mystery that scientists are trying to figure out, and maybe can with the help of the Fermi telescope. So, what is the major instrument of the Fermi telescope? So, it is the LAT, the Large Area Telescope. So, like I said before, gamma rays can't be focused by a mirror or refracted by a lens. So they're detected with a certain kind of technology. So the telescope has what's called a plastic anti-coincidence detector. So the gamma rays go through that. They interact with an atom inside of the telescope, and they produce an electron and a positron from that interaction. They keep going. They create ions in things called silicon strip detectors, and then they're finally stopped by a calorimeter, which measures the energy deposited by the ray. So it's actually a pretty complicated procedure to gather information from the gamma rays. This diagram shows in detail how the Large Area Telescope is constructed. So the Fermi Telescope orbits the Earth in about an hour and a half, 96 minutes. The Large Area Telescope is oriented upwards all the time, so the view is not blocked by the Earth. On alternating orbits, the telescope rocks to the left and to the right so that more of the sky can be covered. So it's covering the whole sky in 2 orbits. When there's a gamma ray burst, then Fermi points at the burst for a while to collect data from it. So, a pretty amazing machine. So what has the Fermi discovered? What have we learned from this big, complicated machine? So the first major discovery that Fermi discovered was a pulsar in a supernova remnant that appeared to emit radiation in the gamma ray band. This is the first. This pulsar was about 4,600, well, is about 4,600 light years away. In September 2008, a gamma ray burst was recorded by Fermi, and it was the largest apparent energy release ever measured. The jet of material ejected in the blast moved at basically the speed of light. So at a minimum, 99.9999% the speed of light. So it was one of the highest energy initial emissions ever seen by scientists. In 2010, Fermi determined that supernova remnants act as enormous accelerators for cosmic particles. So this was one of the missions and one of the reasons that Fermi was launched, was to gather information about supernova remnants. So in March 2010, scientists concluded that active galactic nuclei are not responsible for most gamma ray background radiation. I'm not sure what that means, but it was an important discovery. So in November 2010, two gamma ray and X-ray bubbles were detected around the Milky Way. So they extend about 25,000 light years above and below the center of the galaxy, which is amazing. The Fermi telescope recorded the highest energy light ever seen from the sun in a solar eruption. In 2013, Fermi detected another gamma ray burst with one of the highest energy outputs ever. So the energy output was over 94 billion electron volts. That's insane. And it broke the previous record of the first gamma ray burst that Fermi discovered. So, another really cool thing about Fermi is it has a couple of blogs. There's the Fermi Gamma Ray Sky, and basically this blog is just recording what Fermi is seeing every day in the sky. If you're not a scientist, you're probably not going to understand what this stuff is, but it's still pretty cool to look at. And then there's also the Fermi blog at nasa.gov, and it just kind of relates some of the interesting things that Fermi is discovering to everyday things. For example, in 2012, there's a post that Fermi detected its 1,000th gamma ray burst. Yeah, so that is the Fermi Gamma Ray Telescope. It's a gorgeous machine, and it's going to help us learn more about our universe.